Hello and welcome to this seminar. My name is Rose and I'll be introducing Fred Powers, who will be introducing Jamie Clark. The presentation will be about 20 minutes. If you have any questions, please email me at rose@dimensionalinsight.com or rose@dimins.com. So without further delay, here's Fred. He is the CEO and co-founder of Dimensional Insight, and he's here today to tell you a little bit about this seminar and those that will follow. Fred?
Well, good afternoon, everybody. This is our first company webinar. We wanted to get one in this year. The following will be in January of next year, and then potentially every other month or potentially even every month. We will be focused on both healthcare and goods and services, so there's actually two webinars today. And I really think this will be a good way to convey some further information, all right, to you all. With that being said, we thought that the very first webinar should deal with Spectre, something that has been under development for a number of years. And I could think of no better individual to introduce this product than Jamie Clark. Jamie is a lead developer, architect in Cambridge, has worked directly with Stan and I for over the last 15 years, and it's impossible to think of a major project going on in the lab without Jamie's involvement. So with that, I'm going to ask Jamie to take it away, and we've got about 20 minutes, as Rose said, and then we'll have 10 minutes for questions. So with that, Jamie, it's all yours.
All right. Thanks, Fred, and thanks everybody for joining this webinar. And let's talk about Spectre. So BI databases have been around for a long time, and things have been changing over the years. Spectre is a sort of sign of that change. And I want to start out by talking about a little bit of the history and why certain databases are useful for certain applications. The relational database is sort of the classic database, and we're going to be talking about how Spectre is a columnar database and the differences between relational and columnar. The main difference, as we'll find out later, is that relational databases and columnar databases organize the data in a different structure on disk, and we'll talk about the advantages that that has. But a relational database is usually the first point of contact with data. That's where your transactional systems will be storing all of their information. Your ERPs will be there, and when DI first introduced the model, it was based on that notion of a relational database. The new system, Spectre, is based on the columnar database, which is not exactly a brand new technology, but has been seeing a big upswelling lately due to cheaper technology. So we'll talk about some of those differences. In 1989 was when DI brought out the model, and comparing it to relational databases at the time, it had a lot of advantages going for it. It was automated. It was easier to use and to organize than a relational database was at the time. You didn't need to be a database architect to understand all of the ins and outs of the model. So that was one of its advantages. You didn't have to design and link tables together. Fact and summary tables are created automatically. The summary tables are where the model really gets its performance, and that's why diving was such an easy thing to do. Was one of the major features of the DI model. You didn't have to have the IT resources. Like I said, you didn't have to be the architect of the database. And the model was made for the purpose of diving. It was relational databases were not originally made specifically for that purpose. Relational databases are very flexible. They can do lots of different things. But the model was optimized for the purpose of diving. The way it did that was it would pre-compute summary tables so that when you dig down or dive down to a specific level, the data was ready in advance. It was already computed for you. So let's talk about how the model worked, and we'll use this as a launching point to talk about how the Spectre engine is different and how Spectre cBase is different from the model. The model is a way to organize a table and to prepare that table for diving. On the left hand of this diagram, you can see this represents the detail table, which is the lowest level of data, normalized. And what Builder does when it's creating a model is it looks at all of the things that you might dive on, and it creates summary tables, which sum up the detail table in different ways. It does this once for each dimension. It also does it for each dimension value, and then it's recursive. So for each dimension value, it then goes back and looks at other dimensions. So you end up with, to some extent, a tree of these lower, higher and higher level tables. The summary tables could be considered higher level. It also keeps the original data around, and when you're diving, if you dive past the level which is pre-computed, then it will go back to the detail table. Now, the purpose of all this is basically to make sure that when you do a dive, the data has been computed in advance. For that to happen, a lot of these summary tables need to be computed. So the model is much bigger than the original data, and it takes a long time to set that up. But the advantages are that it's very fast. Now, since that time, there are a lot of things have changed. In this graph, we can see how much money it takes to get a gigabyte of RAM over the years. And obviously, there's a dramatic difference between now and back in the late 80s and early 90s. Memory is much cheaper. Hard drive is also much cheaper as well, and CPUs have gotten a lot faster. So one of the things that was such a big advantage to the model previously, that it required very little system resources to rapidly produce dives, is less of an advantage now than it was at the time. So what we need is to look at ways we can take advantage of the technology we have today. As things have changed over the years, there's been an increasing interest in a different kind of database technology called columnar databases. Columnar databases are not, they're younger than relational databases. And they're very different. They have a lot of advantages and disadvantages. But one of the biggest advantages is speed. So let's look at some of the differences between these two. Relational databases' shortcomings, it's hard to get a large number of columns and dimensions specifically in a relational database without sacrificing performance. When you would set up a database like that, you would tend to have a schema involving primary keys and lookups into other tables, and the more of that you do, the harder it is on queries that use those columns later. And so if we compare that to a columnar database, we're able to use more memory, so we can keep more of the data in memory at a time. The processors are much faster, and we're able to use multi-core processors to do parallel processing. Those are things that would have been possible, but much harder to do with the older system, and plus they would have required heavier investment in resources. That would have been very costly. But nowadays, this is the sort of thing that we can expect out of a new modern database. Columnar databases also handle reporting better. They're structured to optimize data aggregation. So to look at a column of data and compute the sum, that's what a columnar database is for. It's very good at that. Relational database, as we'll see a little bit later, is not structured in a way to help that operation. And one of the things that we'll see with Spectre is that by using Columnar database, we release some of the limits that we used to have, and one of those is on dimensions. No longer need to have a limited number of dimensions. So let's talk about the difference between row major order, and column major order. Almost all of the classic relational databases are structured in row major order, which means that when a table is written to disk or stored in memory, all of the information pertinent to one row is held very close together in memory or on disk. Those bytes packed together. So this means that if you're going to add a row or delete a row, all of that information is in one place. It's a lot easier to do that. But if you're going to do something like scan a column and pull all the numbers out of a single column, you're going to have to jump around a lot because the data is. In this animation, we can see that the way that those rows in that table above will be stored on disk and in memory. I call this row major order, which is to say that if you were to think about the data as being sorted, we first sorted it by row, and then within each row, the columns are organized. In column databases and in Spectre's cBase, data stored in a column major order, as you can imagine, is the opposite direction. This means that if you're going to try to extract a single record from the database, you're going to have to look in multiple places. But it turns out that extracting a single record from the database is not a common operation for business intelligence needs. Most common operation for business intelligence needs are sorting, summarization, and counting and aggregation, other things like that. But the basic idea is, in those cases, we tend to focus on one column at a time, pull the data from that column, and then we work on it, put all the data from different columns together in a separate step. So column major, all the data from one column contiguous in memory or on disk. Now, why does that make a difference? On a computer system, obviously, there are different levels of storage. The disk, I suppose you could say the network is the farthest away and is the slowest to fetch data from. The disk is also very slow. On a scale of computer time, fetching something from disk is one of the slowest things you can do. Memory is much faster, but the memory also isn't the end of that story. There are different levels of cache in between the processor and the memory as well. So the memory cache that sits between the processor and memory is smaller than your main memory, but it is much faster. If the memory is much faster than disk, the memory cache is even faster. Because it's smaller, if you're going to do a lot of operations and you want those operations to be fast, you need to make sure that you fill the memory cache with useful information. Get as much of that useful information into that cache as you can. And this is called locality of reference in software engineering. And so if organizing your data into columns means that when we load a chunk of memory off the disk or off the memory, we bring it into the memory cache, we're more likely to have packed that memory cache with useful information. This makes a huge difference in column aggregation and sorting. So that's the biggest advantage of columnar database. There are some other side advantages, such as we don't need to load columns that are not being used. So if you have a database that has a large number of columns, but your query only needs a small number of them, we're not wasting effort by sorting past the values for those unused columns. In a row-oriented database, you would have to skip those values, and that would waste time. That's actually also the main reason that Spectre database doesn't have a limit on the number of dimensions, because you can add as many columns as you like, and only the ones that you use have an impact on the performance. Now, columnar databases have also their limitations. What you can't do easily with a columnar database is to add a new row or to remove a row. That's why there's always going to be a place for relational databases and transactional systems So what makes the Spectre cBase different from any other columnar database you might find? So we've carried over in Spectre this ease of use and automation that we had with the model. The automation of the model build is something that's very important and makes it possible for you to use software without being a database expert. And that's what we made sure we did with Spectre cBase as well. Also, the Spectre cBase has been optimized in other ways besides simply being columnar to focus on the features that our customers tend to use. We have optimizations that deal with quick use selection and filtering. We have optimizations that are focused on making sure that multi-tabs are fast. And we've done some other things with Spectre that are unique, like adding built-in time series features. We also have this system under the covers, which is very nice for compiling calculations and expressions down to machine code so that we can get every last bit of performance out of the processor. This is something that's pretty rare. A lot of database systems will use an interpreter, and an interpreter is very flexible, and they can optimize a small number of cases, but it's not a general purpose optimization. So in the Spectre compilation process, depending on how your calcs work together, we can actually optimize even more than you would normally do with a standard interpreter by merging all the calcs together and compiling them into machine code. Spectre also introduces a new expression language, which is very flexible. You can do a lot more calculations than you could have done in a model, but also it's not. It adds new expressions that you couldn't easily do in SQL or in other database expression languages. We also have the path for migration from model technology to Spectre. So people who are using our current model technology don't need to see a large change when they move from model to Spectre. We understand both technologies very well, and we can help to move from one to the other. Those are advantages of the Spectre cBase compared to another column database you might find. Now, comparing Spectre to the model, classic model that the DI has always produced, there are a lot of advantages. Spectre does not have a limit on the number of dimensions that you can use, so there is no longer a need to choose the certain dimensions and have to discard others. There's no longer a need to concatenate dimensions. Spectre can handle larger data volumes than the model could with much faster build times. So there's no longer a need to build your models in pieces and consolidate them after the fact, which was a performance hit with the model system. So in Spectre, you can build everything at once into a single table at a single point of reference. Spectre also, like I said before, has an optimization for multi-tabs. Comparing to models, Spectre really eats up multi-tabs. One of the problems with the model was that there was a cliff. If you added enough dimensions to your multi-tab, you could end up with a report that takes significantly more time. And with the Spectre system, that's not the case. Multi-tabs do not add significant time to the report processing. Spectre adds an integrated time series to the Spectre system, so date and period values are first-class values in Spectre, which makes it easier to write expressions that deal with dates than in the model system. I mentioned that we don't need to break up models to consolidate them. You don't need to choose the summary types in advance because Spectre does all of its processing at runtime, where the model would have needed to know during the build whether you wanted to do certain summary operations like maximum or minimum or average standard deviation. Spectre system doesn't need to know that. You can choose the summary types after a build. Spectre also includes parallel processing because we are taking advantage of the multi-core CPUs that are now available, and the Spectre system makes sure to use as many cores as possible in computing. Calcs are compiled to machine code, as I mentioned, and there's a new expression language. And we're ready to migrate from models to Spectre. Have that knowledge, and we can help out with that migration system. So those are the advantages of Spectre, and I hope that everyone has come away with at least a little more information about what a columnar database is and how it helps process business information, and why Spectre is so exciting for Dimension.
So, Jamie, I want to thank you very much. As you can see, we're right on time at 20 minutes. We've allocated 10 for questions. And again, if you would like to send a question to Rose, R-O-S-E, at demins.com, we'll gather those up. And we do have a couple of questions that have already come in. And so I'm going to pass these over to Jamie, and he can choose one of these and give us a little bit of an answer.
All right. One of these is someone asked, how do I upgrade to Spectre? If you're using the model technology, we have a pretty smooth process to upgrade. We tend to go in steps. You'll want to start with upgrading to 7.0 if you're not already using our 7.0 product line. And once you're in 7.0 and you have the license to use Spectre, you can actually start to use the model and Spectre technologies simultaneously, side by side. So you can actually create new content in Spectre using cBases while your old content is still using models. And then on top of that, we have the ability to swap out a set of models for a Spectre cBase. So if you've taken some of your models and you've converted them to cBases, you can run through all of the markers we have and decide which markers should be converted to cBases, and you can basically automate the process. Now, of course, there's always things to look out for. When we're doing migration, you're going to want to be careful to do some testing. But we've taken pains to make sure that the marker doesn't need to be changed. Basically, all you're doing is swapping out the data storage component. We'll be offering Spectre training at the 2017 Users Conference. Of course. Of course we will. We always have training at the user conferences, and I have a feeling that the training at this year's user conference, next year still, will definitely be Spectre heavy. So you can look forward to that if you're intending to go to the Okay. Yeah, there was right. The question says, I heard that you did a live benchmarking test at one of the user conferences. Chance I could see a video recording of that test, or if not, we'll be able to see a benchmark test if I request a demonstration. The answer is definitely yes to those. We did do at 2 years ago, when we unveiled Spectre originally at a user conference, there was a segment where, if I recall correctly, it was Mike who did a demonstration showing the two products side by side, showing performance. I'm sure we have the video of that, so we can look that up. But definitely, if anybody needs to learn more information about Spectre and wants to ask for a demonstration, we can help out with that. Give another. Go ahead. Yeah. Yes. Okay. So so I have a question. Can Dimensional Insight convert models to cBases for existing installations when upgrading to Spectre? And I touched on this earlier, that technically speaking, it's not a conversion of the model. We can't read in a model and then just write out a cBase just like that. There are differences between the two database systems. So, do we convert the model to a cBase? Not exactly. But if you rebuild the data as a cBase instead of as a model, and we can convert the build script from a model to a cBase. We can do that much at least. If you do that, and then you build a cBase out of your data instead of a model, the rest of it can be swapped out by batch modifying all the markers. Yeah. Okay. Another question: if we have hospital dashboards / PPA / meaningful use, would PI upgrade those models to cBase so they can utilize the speed and power of Spectre? That's something that Fred may have to address. What do you think, Fred?
I think the answer is yes, but it's a qualified yes because there's a fair amount of underlying technology to support both PPA and meaningful use. And I am in contact with Roger Williams, one of our lead consultants, in terms of how we would actually go about that. And outside of the fact that Roger is looking into it, he has not gotten back to me at this point in time in terms of how we would actually proceed. But let me just add, there is a fair amount of complexity here, especially on the PPA side. So it will be almost a total rewrite. It's not just a matter of swapping out a model for a cBase, because there was a fair amount of tunneling and other techniques that were included for the speed. So it would be a total rework.
Another one here: can you give examples of your flexible expression language for unique queries? Unfortunately, I don't have any slides I can call up right now that will show some of these expressions, but I can talk briefly about some of the more interesting ones. So beyond what the model can do, Spectre can do calculations at the detail level, which would not have been possible in model ProDiver. In ProDiver, you always have to work at the summary level, with some exceptions such as filtered dim counts. But there are some expressions that you can write which focus on the detail level in Spectre that you can't do in ProDiver. And another one that I hope someone out there can find a use for, but it's really an amazing expression, is called squash. And what the squash function does is it actually generates row by row an additional side table where further summary operations take place before being pulled back into the table that's being run. So to give an analogy, if I can hopefully make this make some amount of sense, the squash function is like running a query within your query. There are certain cases where that's very powerful and very useful, but it definitely takes a clever mind to see how that all fits together for that particular expression. So Spectre has basically given us the opportunity to add a whole bunch of these new functions that do advanced things that just would have been impossible in the old calc system. Here's another question. Will this... Okay. Yeah, we can have Fred answer this one. The question...
Yeah, so the last question is, will the PowerPoint be sent out to the attendees so it can be shared? And the answer to that is yes. It will be sent on out along with a questionnaire that I would appreciate that you spend maybe 20 seconds filling out so that we can improve these. Rose will be sending that out either certainly this week, so certainly expect it within the next day or two. It is now 1:30, and I want to thank everybody that attended. If we do not speak again, certainly have a good set of holidays coming up. And with that, I thank you all. And Rose will get the PowerPoint out to you ASAP. Thanks again.